Good day, everyone. Our topic for today is representation of logarithmic functions. How are we going to represent logarithmic functions? Through its graph, its equation, and its table of values. Let's do it. Let us recall first the definition of logarithmic function. It is defined by f of x is equal to log of x to the base b. Remember that b here should be greater than 1, or it can be less than 1 but greater than 0. Meaning this one can never be negative. Okay. Remember that this is equivalent to y is equal to log of x to the base b. Suppose you have f of x is equal to log of x to the base 3. This one is y is equal to log of x to the base 3. Why did I say that this one should always be greater than 0? Because no matter what your exponent is, you cannot get a value that is equal to 0 or less than 0. Why? Suppose I will be putting here 1. So this is 3 raised to 1. I will change it into exponential is equal to x. Okay? So that is 3 raised to 1 is equal to x. This one. So any number that can be placed in here, we cannot get a value of x that is equal to 0 or less than 0. So meaning to say, it is always greater than 0. Okay? Example number 1. Log of x to the base 2 is equal to y. Remember that this one can also be written as y is equal to log of x to the base 2. I already assigned values for x so that I can solve for y. I have chosen these values because if I will be replacing x by these values, I can get a whole number value for y. Sample. Log of, I will replace x by 1/2 to the base 2 is equal to y. Okay, how do we evaluate this? You can use the change of base formula, that is you just divide log of 1/2 by log of 2. And you will be getting there -1. Or you just think of an exponent of 2 that is equal to 1/2. What must be the exponent of 2 that it will be equal to 1/2? And that is -1. Same as 1/4. That is log of 1/4 to the base 2 is equal to y. Just think of an exponent of 2 that is equal to 1/4. Of course, -2. So that is 1/4 is equal to y. Or you just divide log of 1/4 by log of 2 and you will be getting there -2. Okay. What about if x is 1? What about if x is 1? If x is 1, that will be 2 is equal to y. Remember that 2 or any base raised to 0 is equal to 1. So 2 raised to 0 is equal to 1. Therefore, our y there is 1. Or you just press log of 1 divided by log of 2. And of course, we have there 2. What must be the exponent of 2 that is equal to 2? That is, of course, 1. That's why our y is equal to 1. Okay. Now, we are now ready to graph this. Remember that logarithmic function is the inverse of exponential function. So that is 1/2, 1, it's here. And then 1/4, -2, it's here. And then we have 1, 0, it's here. And we have 2, 1, it's here. Okay. This one is a graph which is asymptotic to, of course, x equals 0. Because remember that x is always greater than 0. Now, what about the second? The second is log of x to the base 2 plus 2. Meaning, we will be getting first log of x to the base 2 before adding it to 2. So, I assigned again 1/2, 1/4, 1 and 2 for x. Okay, so we have there log of 1/2 to the base 2 plus 2 is equal to y. Okay, we know that this one is equivalent to negative 1 plus 2 is equal to y. So this one is equal to y. Okay, so same if we have here 1/4, this one is negative 2 plus 2, that will be 0. If we have here 1, this is 0. 0 plus 2, it's 2. If we have here 2, this one is 1 plus 2 is equal to 3. Okay, so let's graph it now. Let's see the behavior of the graph. So we have 1/2 1. Where is 1/2 1? 1/2 and then 1. And then we have 1/4 0. 1/4 0. This one. And then we have 1 2 1 2. This one. And then we have 2 3. This one. Okay. Notice that the behavior of the graph is still the same. So meaning to say there is a shift in the graph. Meaning if this one is plus 2, we just move all the points 2 units up. If it is minus, we just move the graph, the base graph, 2 units down. Okay, let's graph the third one. The third one is log of x to the base 2 minus 3 is equal to y. Again, you have to evaluate this first before subtracting it by 3. So that is 1/2 negative 4. Where is 1/2? It's negative 4. 1 2 3 4. And this is 1/2. Okay, it's here. And then you have 1/4 negative 5. This one is negative 5 1/4. And then you have 1 negative 3. This is 1 negative 3. And of course, 2 negative 2. Okay. 2 negative 2. Okay. So notice that the base graph here moved down through 3 units. So that is 1 2 3. 1 2 3. All points should be moving down 3 units. Example number 4. Log of x plus 1 to the base 2 is equal to y. Take note that this time, x is added to 1 first before we get its logarithm. So that is, I have assigned already values for x again so that I can get a whole number value or exact value for y. Okay, let's do the first one. This is log of negative 1/2 plus 1 to the base 2 equals y. We know that 1/2 negative plus 1 is 1/2 to the base 2. You can use calculator in getting the value of this. You just use the change of base formula, log of 1/2 divided by log of 2. That will be equal to negative 1. Or you just think of an exponent of 2 that is equal to 1/2 and that is negative 1. Now, what about if I will be putting here negative 3/4? Of course, negative 3/4 plus 1 is 1/4. Again, I will just think of an exponent of 2 that is equal to 1/4 and that is negative 2. Or you can just press log of 1/4 divided by log of 2 in your scientific calculator and you will be getting negative 2. If x is replaced by 0, this one is equal to 1. Okay, think of an exponent of 2 that is equal to 1, that is 0. And of course, if I will replace it by 1, that is 1 plus 1 equals 2. Think of an exponent of 2 that is equal to 2. Of course, that is equal to 1. Now, let us graph it. We have negative 1/2, 1. negative 3/4, negative 2, 0, 0, and 1, 1. Okay, so this one is the graph. Okay, so if that is the graph, of course, y equals log of x plus 1 to the base 2. What can you say? What did you notice? Take note that if this one is added by 1, all points from the base graph are moved 1 unit to the left. Okay, so meaning to say if this one is plus 1, you have to move all points on the base graph according to, of course, the one that is added here. So if it is 2, you move 2. If it is 3, you move 3 to the left. Therefore, we can conclude that if this one is minus 1, we have to move all points of the base graph to the right. Okay, so let's do it. Let's see if it is really true. Okay, I assign 1 and 1/2 there, you will be getting negative 1/2. I assign 1 and 1/4 there, you will be getting negative 2. I assign 2, that will be 0. I assign 3, that will be 1. Let's graph it. So we have 1 and 1/2, negative 1. 1 and 1/2, this is 1 and 1/2, negative 1. Okay. So we have 1 and 1/4, 1 and 1/4, this is negative 2. And then 2, 0, 2, 0. And then 3, 1. 3, 1. That's it. It's true, right? It's true that if this is minus, you have to move all the base graph to the right. Take note that you have to draw first the base graph before you do the movements. Okay? Let us represent the graph of this function. Log of x to the base 1/2 is equal to y. Take note that our base here is less than 1 but greater than 0 this time. And again, I assign values for x so that I can get an exact value for y. Take note also that I will not be graphing all, but this time I will be using this one as a reference point. Okay, or as a reference graph rather. Okay, we have x is equal to 1, 1/2, 2, and 4. So if x is 1, that will be 0. If x is 1, that will be 0. Okay. Next, if x is 1/2, that will be 1. 1. 1/2, 1. If x is 2, that will be negative 1. And if x is 4, that will be 2, 3, 4. This is negative 2. Okay. So this is the graph. Again, this is the asymptotic to the x is equal to 0. Okay. So this one. Now, I will not be making a table anymore for this, but I know that if it is plus 3, I will just move all the points up 3 units. And if it is minus 2, I will just move all the points from here 2 units down. If this one is plus 5, we'll just move 5 units to the left. Okay, let's do it. So x plus 3, we have to move all units up. That will be 1, 2, 3. And then we have this one that is 1, 2, 3. And then this one, 1, 2, 3. And then this one, 1, 2, 3. Okay, so this one is the graph. This one is y equals log of x plus 3 to the base 1/2. And this one is log of x to the base 1/2 is equal to y. Okay. What about this number 3? So this is x minus 2. I will be moving all points 2 units down. So this is 1 and 2. This is 1 and 2. This is 1, 1 and 2. And this one is 1 and 2. Okay. So here is the graph. Okay? Now, y equals log of x minus 2 to the base 1/2. And then for number 4, this one is plus 5. So I will be moving all points 5 units to the left. Okay, so let's do it. 1, 2, 3, 4, 5. This is 1/2, so that is 1/2, 1/2, 1/2, 1/2. 1, 2, 3, 4, 5. And then this one, it's 1, 2, 3, 4, 5. And then the last one, 1, 2, 3, 4, and 5. So this one is the graph. Oh, okay. So this is y equals log of x plus 5 to the base 1/2. That's it.